All right, hey guys, Algebra 1, spring final. As you're watching us right now, you should have Mr. Facente subbing, and we're going to go over specifically Units 1 and Unit 2. Just to go over like the logistics of the final. It's a 60-minute final. You get a 4-function calculator. You get a note card. You can replace your lowest test score of the semester with this grade if it is higher. This packet has all the concepts that are going to be on the final, or that could be on the final. And then there's more practice from the Delta. When it comes to preparation, you can, you want to complete this packet, watch my videos, do the Delta review, complete the practice final, and come to office hours / academic collaboration for help. Okay, we're going to start off with some Unit 1 review, Chapter 1, solving equations. Remember, the whole goal of solving equations, solving linear equations anyway, is just to get the x alone. That's the goal. We just want to get x alone. So if you know how to do these, I recommend that you try them and then watch the video. Okay, here we go. I hope you've tried them. So first one, I'm just going to add 5, both sides. 2x equals 12, and we're going to divide by 2. We're going to get x equals 6. Okay? Next one, we're going to the same thing. We're going to subtract 2 both sides. We're going to get 3y over 2 equals negative 15. Then I'm going to multiply by 2 on the left, multiply by 2 on the right. It's going to cancel out that 2. We're going to have 3y equals negative 30, and then I'm going to divide both sides by 3, and then y equals negative 10. Okay? Variables on both sides. 5x plus 3 equals 2x minus 9. We want to get the x just on one side and then the constant terms on the other side. So numbers on one side, variables on the other. So that means I'm going to do minus 2x on the right, minus 2x on the left, minus 3 on the right, minus 3 on the left. What it's going to get me is 3x equals negative 12. Then I'm going to divide by 3, and x equals negative 4. Okay, with distribution. So here, we're just going to multiply out and then solve. So we'll have negative 2x minus 2 equals x plus 3. I'm going to add 2x to this and this side, and then minus 3 this side and this side. I'll get negative 5 equals 3x, and so negative 5 over 3 equals 3x, because I'm dividing by 3 here and here. Okay? Weird solutions. So we can have situations where we have no solution. So in this case, once I multiply this out, I'm going to get 2x plus 2 minus x. That's x plus 2 equals x plus 3. And then I subtract x both sides. I get 2 equals 3, and that can't be, so this is no solution. When we have another weird solution case, this is all real numbers. So once I combine like terms here, I'm going to get x plus 5 equals x plus 5. Well, this is true for all numbers. This is all real numbers is the solution. Because no matter what I put in for x, it's the same both sides. They will always equal each other. Okay, absolute value. Remember that absolute value turns the x positive. So the absolute value of 8 is just 8, but the absolute value of negative 8 is 8. It just turns the value positive if it's not already positive. So that means when we have an absolute value, the inside can either equal the positive or the negative of what's on the other side. And so we apply that rule to everything. We can have x plus 5 equals 8, or x plus 5 equals negative 8, and we solve. So x equals 3, and x equals negative 13. Right, subtracting 5, subtract 5, subtract 5, subtract 5. Same thing here. 2x minus 4 equals 8, or 2x minus 4 equals negative 8. We're going to add 4 both sides. We're going to get 2x equals 12, 2x equals negative 4, x equals 6, x equals negative 2. Okay? Down here, before we go ahead and set it equal to positive negative 8, we're actually going to simplify this and divide both sides by 2. Get x minus 3 equals 4. Absolute value of x minus 3 equals 4. And then we're going to split it up. X minus 3 equals 4. And x minus 3 equals negative 4. So x equals 7. And x equals negative 1. Same thing here. We're going to get an absolute value alone before we set them equal. So plus 1 first, both sides. We're going to have absolute value x plus 3, absolute value x plus 3 equals 9, and then divide by 3, and we have absolute value x plus 3 equals 3. And then now I can write my two equations. X plus 3 equals 3, x plus 3 equals negative 3, x equals 0, x equals negative 6. Here, an absolute value cannot equal a negative number. That's impossible, so this is no solution. The absolute value cannot equal a negative number by definition because absolute value turns it positive. No solution. Solving for a variable. A equals 1/2 BH. Solve for B. So that just means get B alone here. So if I want to get B alone, I'm going to first multiply by 2.
Do I have to come in first?
Stay. Stay. After multiplying by 2, we're going to have 2a equals bh. And then to get b completely alone, we're going to divide both sides by h. And so we have 2a over h equals b. Okay. Solving inequalities on a number line. So you want to get x alone, just like you would with an equation, and then we're going to graph. So get x alone, we're going to add 5 both sides. X is greater than or equal to 14. And then we draw our line, we mark 14. It's going to get filled in because it's got that equal sign. And it's just going to go to the right because x is greater than or equal to 14. Oh, did you see that? Okay. For the next one, same idea. We're going to add the 3. We're going to add the 3. 2x is less than negative 2. We're going to divide by 2, divide by 2. We're going to have x is less than negative 1. Same idea. Negative 1, but it's going to be open because it's not got an equal sign, and then it's going to the left. Okay. So here we have 5 is greater than or equal to x, right? This is the same thing as saying x is less than or equal to 5. So when we draw it, we have 5 filled in to the left. Here, so we can rearrange an inequality so it's more readable. These say the same thing. Here, we're flipping because we are going to be dividing by negative 3. Whenever you divide by a negative number or multiply by a negative number, you must flip the sign. So if x is less than negative 3. Okay, so same thing. We open at negative 3 and head to the left. In-betweeners. This is like an and statement where it's between the values of negative 2 and 7. So we mark both of them. It's going to be open at negative 2, it's going to be filled in at 7, and we link them just like that. Here, we can solve them all at the same time. So we add 1 to all 3 sides. 4 is less than or equal to 2x is less than 16. Then divide everything by 2. We have 2 is less than or equal to x is less than 8. So from 2 to 8, filled in at 2, open at 8, connected. Okay, solving absolute value inequalities. So remember greater, less than, great, or, less than, right? Remember this? So greater, x plus 3 could be greater than 5, or x plus 3 could be less than negative 5. So it could be 5 or greater, sorry, not 5 or greater, it could be greater than 5, or it could be less than negative 5. Because we're taking the absolute value, those two are equivalent statements. So we flip the sign and the inequality. Both of these get flipped. So this becomes x is greater than 2 and x is less than, or x is less than negative 8. So from 2 above and from 8 and below. Negative 8 and below. Okay. Same thing here. We're just going to divide by 2 first. 2x minus 1 less than or equal to 4. So less than 2x minus 1 is less than or equal to 4, and 2x minus 1 is greater than or equal to negative 4. So we get 2x less than or equal to 5, x less than or equal to 5 over 2, and 2x greater than or equal to negative 3, x greater than or equal to negative 3 over 2. So connect the dots. All right. Same idea down here. Add 10, 5, x plus 1, greater than or equal to 10, divide by 5, also x plus 1, greater than or equal to 2, greater, so x plus 1 greater than or equal to 2, or x plus 1 less than or equal to negative 2. So x can be greater than or equal to 1, or x is less than or equal to negative 3. So negative 3, 1, just like that. Last one, less than. We're going to add 5 and divide by negative 2, so we're going to get 20. We are then going to divide by negative 2, which means flipping the sign. So we're going to have x plus, well, absolute value x plus 1 is greater than negative 10. So it's actually going to change it to a greater. So it's going to be x plus 1 is greater than, oh, this is impossible. Let me pause for a second. An absolute value can, no, this is, sorry, this is fine. X plus 1 is greater than negative 10, yeah, or x plus 1 is less than um, 10. Okay, so that means x is greater than negative 11, or x is less than 9. So it would be from negative 11 up and from 9 and below. So this is all numbers. That's why I for a second I was like, oh, this is impossible. The reason I said that is because this is true for all numbers, right? All absolute value means positive. All positive numbers are going to be bigger than negative 10, so that's why it's true for everything. Okay, that is going to be it for today. We did chapters 1 and 2. When you're done with this, take a look at the delta, and I will see you next class.